Hello, welcome to the fourth lesson in Spiral 3, and we're looking at interior and exterior angles of quadrilaterals. So I want you to be able to understand the interior-exterior angles and be able to find or determine different applications. So basically, we're just working with the angles. Now, this particular note says determine the sum of the internal angles for the following shapes. You may need to use a protractor. So obviously, you're watching the video, so I'm going to walk you through this. So we know that the triangle has three sides, and we know that it has 180 degrees in here, okay? That angle plus that angle plus that angle is 180 degrees. Hopefully you're good with that, okay? This shape, four sides, obviously, and when you add up the angles inside, we end up with 360 degrees. Now we move to a five-sided object. So this one has five sides. So we need to find the pattern. And I know it's a limited example here, a limited pattern. But to go from three sides to four sides, we added 180. And the nice thing is the pattern continues. So we add 180. So if you were to go through and do this as a task, adding using a protractor, you would find that this five-sided object has 540 degrees. Here we have 1, 2, 3, 4, 5, 6. So we've gone to six sides. And if we add the 180 again, this one turns out to be 720. And just speeding the process up, we have 900 and 1080. All right, so you would have done this as an investigation for me in class. However, obviously you're not with me. So that's what the results approximately would have been. All right, so let's see what the rule is here. So we filled out all that information on the previous page. All right, so transferring over. So we have 360, and I gotta look back here, sorry, 540, 720, 900, 1080, and it even goes one more, 1260. Okay, so we know from Spiral 2, we did linear relations, and you had to find first differences. So we already discussed, okay, 180 is our pattern here. All right, so we came up with a rule, or developed a rule here. So we basically had to figure out how did 3 become 180. And in Spiral 2, we said, well, we always multiply by the first difference. So it's going to be 3 times 180. And we'll do the first couple here. 4 times 180, 5 times 180. The trick then becomes, is what has to finish this off to make these statements true. So 540. So if we do a quick calculation here, 3 times 180, well, this comes out to be 540. 4 times 180 is 720. 5 times 180 is 900. So what has to be added to here to make this statement true? So if we have 540, if I subtract the 180, it means I'm too high by 360 degrees. So that means I have to do 3 times 180 minus 360. All right, so let's see if this works. So on my calculator, 4 times 180 is 720. If I subtract 360, we get 360. 5 times 180, so now I have 900 minus 360, and that turns out to be 540. So I've figured out my pattern or my rule. So the 345 is sides multiplied by 180, subtract 360. So there is our rule or equation to determine the number of degrees or the sum of the angles inside a multi-sided shape. All right, do you have to memorize this? No, because you can create your T-chart again and find the pattern and figure it out from there. All right. All right, so let's try some examples here. So example 1. So this is a four-sided shape or quadrilateral. This is four-sided. I don't want to write the word quadrilateral, can't spell it. It has 360 degrees. So any four-sided shape has 360 degrees. How can you remember that? Well, remember, if you cut any four-sided shape in half like that, it's a triangle. Triangles have 180. So you've got two triangles. So 2 times 180, 360. Anyway, how do we find the missing angle? Well, if we know we have 360 degrees inside this particular shape, we can then subtract 119. So we'll just take away all the angles. Minus 61 minus 119. So when you punch that through the calculator, it turns out to be 61 degrees. So therefore, C equals 61 degrees. All right, so you can just do sum of the angles, same as what we did with triangles in spiral 1. A loonie is a regular 11-sided polygon, so that has 11 sides. What is the measure of each angle inside a loonie? First thing we have to do is we have to find total degrees, I'll call it. So that means we're going to have to go back and use that relationship we came up with. All right, so we're going to have to use this relationship right here. All right, so we take our sides, we multiply by 180 and minus 360. So we have 11 sides. We're going to multiply by 180 and subtract 360. So if you were to measure each angle inside the loonie, you get 11 times 180 minus 360, 1,620 degrees. So there's step 1. All right. If it asked us what's the total or the sum of the angles inside, then we'd be able to say we're done with 620. But they want to know the measure of each angle. So we're going to assume that each angle is the same. So in step 2, each angle, we're going to evenly distribute the 1,620 degrees. So we're going to evenly distribute them with 11 corners. All right. Triangle has 3 sides, 3 corners. Square has 4 sides, 4 corners. 11-sided object has 11 sides, 11 corners. So we take the 1620 divided by 11, and we end up with 147.3 degrees. All right. So there we are. That finds the individual angle inside the loonie. In example 3, which is our final example, it's a parallelogram. So we have parallel sides here. So with a parallelogram, it has some special properties. With the parallelogram, opposite angles, excuse me, are actually equal to each other. All right. So if opposite angles are equal, that tells me that angle J, so therefore J has to equal 48 degrees. How do we find H and K? Well, we know that we have a total, so step 1, step 2. Inside here is 360 degrees. If I subtract 48 and 48, because I know 2 of the angles, I end up with, 360 minus 48 gives me 264 degrees. These 2 angles add up to 264 degrees, and they are equal. So H and K are equal, and they share that 264 degrees. So we divide that by 2, and each of them will be 132 degrees. All right, so if you have any questions, make sure you ask your teacher for some help. Good luck with the problems in this particular section. It can be challenging. The formula, always tricky to remember. This one here. So for the most part, you can use your patterning to figure it out. If you forget that formula, it's not going to be on a formula sheet. So just as a heads up, if you have any questions, make sure you ask, and we'll see you in the next video.